Hello, and I want to welcome you to example 2 of solving linear systems in 3 variables by elimination of variables. So we have the example 2 of 2x minus 4y plus 3z equals 17, x plus 2y minus z equals 0, and 4x minus y minus z equals 6. Okay, so what I would recommend doing for this problem is first taking the second and third equation and solving for y. And I say y because those are pretty nice looking variables that you can solve for. Z would also be a very good variable to solve for, but in this case I'm just going to wait and I'm just going to go ahead and solve for y. And in blue I will be solving for the third equation, and in red I will solve for y in red ink of the second equation. So going with the third equation here, let's go ahead and solve for y by subtracting 4x on both sides. And let's go ahead and add z to both sides to get it all out in one step, since there's so much to do. So we're going to be left with negative y equals 6 minus 4x plus z. Now, what you would equivalently do is divide by a negative 1, or in this case you can just go ahead and change all the signs in the equation. So you're left with a positive y equals a negative 6 plus 4x minus z. Okay, and let's go ahead and box that in, because we're going to use that in just a little bit. Okay, now in red, I'm going to take the second equation and solve for y. And to do that, you want to subtract x on both sides, as well as add z. And when you do that, you're going to be left with 2y equals a negative x plus z. Now to finally to get y by itself, divide by 2 on both sides of the equation, leaving you with just y equals a negative x plus z divided by 2. Let's go ahead and box that in as well. Okay, so what you can now notice is that we have two things that y are equal to. So let's set that equal to each other. So in red, let's continue what we were just working with of negative x plus z divided by 2. And in blue, let's have the equation that we worked with previously of negative 6 plus 4x minus z. Okay, and in this case, let's try to solve for, let's try to go for z, because z looks like it'd be pretty easy to work with. So, to start solving, what I'd like to do is get rid of this 2 in the denominator. So to do that, let's multiply 2 on both sides of the equation. What that's going to do on the right hand side is going to cancel out the 2. But on the left side, we're going to have to distribute that 2 across everything inside. So we're going to have 2 times negative 6 plus 2 times 4x plus 2 times a negative z equals, and over here you can just note that these 2's will cancel out, leaving you with just what's in the numerator of negative x plus z. Now let's go through on the left hand side and simplify our multiplication. 2 times negative 6 is negative 12, and then 2 times 4x is 8x. Then we have 2 times negative z gives you a negative 2z, and again equals negative x plus z. Now let's get the z's on one side, and let's get everything else on the other. And to do that, let's just add 2z all sides of the equation. And when we do that, we're going to have a negative 12 plus 8x equals negative x plus 3z. Now I'd like to get that x on the other side by adding it to the other side of the equation. So let's add x on all sides of the equation. When doing that, you're going to get negative 12 plus 9x equals 3z. Now to get z finally all the way to itself, let's divide 3 on all sides of the equation. When you do that, you're going to be left with z equals negative 12 divided by 3 is going to be a negative 4. Then you're going to have a positive 9x divided by 3, leaving you with just a plus 3x. Now let's just box that in as well. Give me just a second, I'm going to extend the page. Okay, so where we left off, we just found that z is equal to negative 4 plus 3x. So now what I recommend doing is taking what we had y equal to. Y was equal to, if you remember, a negative 6 plus 4x minus z. What I recommend doing now is taking what you have for z and plugging it in. So you're going to be left with negative 6 plus 4x minus, and then just fill in what we found x to be, which was negative 4 plus 3x. So going through and simplifying, we have y equals negative 6 plus 4x, and with this negative sign to distribute across, it just changes the sign of everything inside. So we're left with a positive 4 minus 3x. Now simplifying further, we have y is going to be equal to, it's going to be a negative 6 plus 4, or just a negative 2. We have 4x minus 3x, or just plus x. Let's circle that. Now, what I would recommend doing is taking the equation that has not been worked with yet, this equation right here, the 2x minus let's take the equation 2x minus 4y plus 3z equals 17, and let's plug in what we have for the y and z, since that's what we found so far. And I'm going to extend the page some more because we still have a lot of work to do. So taking what we have of plugging in, so we have 2x minus 4, and what we found for y was a negative 2 plus x plus 3, and then in for z, we're going to take the negative 4 plus 3x. And if you notice, everything is in terms of x, so we will actually be able to find what x is from doing all this work so far. Going through and distributing everything, we have 2x, then we have the negative 4 times negative 2 minus 4 times x plus 3 times negative 4 plus 3 times 3x equals 17. So let's go through and simplify. So we have 2x, negative times a negative is a positive, 2 times 4 is 8, then we have a negative 4x, alright, and then a negative times positive is a negative, 3 times 4 is 12. Finally we have 3 times 3x will give you a positive 9x equals 17. Let's combine all of our x's together, and when you do that, I believe you will see that there will be 7, because 2x minus 4x is a negative 2x plus 9 gives you a negative 7x, or positive 7x, excuse me. And when we add our numbers, we have 8 minus 2 is going to be a negative 4, equals 17. Let's add 4 to both sides. So you're going to be left with 7x equals 17 plus 4 is 21. And again, let's extend the page. So let's get 7 by itself by dividing it to both sides of the equation. So you're left with x equals 21 over 7, or just x is equal to 3. You've actually found one piece of the set you were looking for. Now, what you want to do is what you found x and z to be equal to, just find those and plug them in for x. So you found y was equal to x minus 2, and since we know x is equal to 3, just take the x and replace it with 3 in the equation. So now x is equal to 3 minus 2, or just y is equal to 1. Okay, and then for z, you found z was equal to 3x minus 4. Now just find the x in the equation, replace it with 3. So we have 3 times 3 minus 4. So 3 times 3 is 9 minus 4. So z is equal to 5. So that was a lot of work, but now just making our last understanding of x, y, and z in our coordinate pair. Remember, x will be 3, y will be 1, and z will be 5. And that is the answer to this problem.